So let's apply linear momentum, the conservation, that is the law of conservation of linear momentum, and see how it's useful and understand a concept that we are familiar with. So that is to do with gun and stuff. So first thing is, let's look at before we fire a bullet and after. Okay, before we fire a gun or a bullet, whatever that is called as. So what we have here is, okay, so what we have here is the gun and the bullet are stationary. So if I call the gun as, the mass of the gun as mg and mass of the bullet as mb, and the velocity of the bullet, initial velocity, will be 0 meter per second, and the initial velocity of the gun is also 0 meter per second. Nothing is moving. Now once we fire, what happens? So the thing is, the gun, let me actually take this itself. The gun will, okay, more than the gun, I'll tell, the bullet will go forward. At the same time, the gun will go a bit back. It has to go a bit back because of, yes, third law of motion. So for every action, so something is moving forward, there has to be a reaction, something has to go back. Okay, now we'll apply the concept of as per the law of conservation of linear momentum. What we have is total momentum before we fire. This has to be equal to total momentum after the firing. So what is the total momentum? Well, momentum of the bullet plus the momentum of the gun. So momentum of the bullet is mbup and mgug. This is equal to mbvb and minus, oh sorry, in vector form, minus mgvg. I'm taking right as positive. Okay, so this negative is because of the fact that gun recoils in opposite direction to that of the bullet. So this is explained by Newton's third law. Right guys, so when you substitute the values and stuff, substituting say ub and ug, so this LHS will be equal to 0. Then we have mb vb minus mg vg. A bit of rearranging and we have the velocity of the bullet is equal to mass of the gun by mass of the bullet times mass of the, sorry, velocity of the gun, and velocity of the gun is equal to mass of the bullet by mass of the gun times Vp. Is it not? So generally, what is the funda? Generally, it's that mb is much lesser than mg. Mass of the bullet is much, this means much lesser, much lesser So this being the aspect, so if MP is much lesser than mg, what can we tell? Yes, VB will be much greater than VG, because velocity and the mass are inversely proportional. Because velocity and mass are inversely proportional. And that's that. So what does it mean? That yes, even the gun moves, but its velocity is very small compared to that of the bullet. Okay, so that's what it means. Of course, you guys can see there are many artillery guns wherein it shakes the entire space around it. Right? We have big fat bullets flying around. I mean, when in the border, that is during peak, terrorist infiltration or ceasefiring violation and all of that. So you can see that you have the ground shaking. Right? Bullets are going forward. It's the gun, right? Technically not a gun, but point is a device that is pushing it forward. That shakes so much because VB has to be that big and the bullet is that heavy and so on and so forth. So in that case, things are different a bit. But point is, here, see, it's common sense. Like bullet goes faster than gun. There's a bit of pushback. If you guys didn't know that, you can watch the gun recoil video. Okay, recoil of a gun. You can watch that. You will understand it. So here the point is that we can use a very simple concept of law of conservation of linear momentum and understand physically with mathematics and with words, with symbols, we are able to describe what happens when we fire a gun. That's the gist. If not, it's a very simple concept and a very simple proof. So understand the practicality of all of these topics. Okay, so that's the point of this conversation. Please put this heading. And yeah, you need to copy this.